Salam sejahtera. This is an example of ideal Rankine cycle. Sketch TS diagram and determine the thermal efficiency of this cycle. So if we look at this cycle, we have pump here, boiler, turbine as well as condenser, and the liquid that enter the pumps is 75 kilopascal and the liquid is compressed and it will cause the pressure is increased to 3 megapascal as well as temperature is increased. So with the high temperature and high pressure, the liquid enter the boiler and it will heat up by the boiler. So there will be Q in here and the process is in constant pressure. So at the inlet of a turbine, okay, the liquid is in superheated vapor. And the high temperature here, 350 degrees Celsius of the superheated liquid and the pressure 3 megapascal will enter the turbine, and in the turbine there is an expansion process that cause the turbine will produce W dot output and the pressure will reduce to 75 kilopascal as well as temperature will reduce. So the liquid will enter the condenser. So in condenser, there will be a constant pressure heat rejection before it will enter again in a pump in a liquid phase. So how to sketch the TS diagram? So this is a TS diagram. You have to know how to sketch the TS diagram. First thing first, we have to sketch the constant pressure. Since we have two pressure here, that is 75 and 3 megapascal, then we sketch 75 kilopascal. This is the pressure at a pump and condenser. And 3 megapascal, that is in a boiler and inlet of turbine. So we have two constant pressure line. Okay, and 122 is adiabatic process or isentropic process in compressor and isentropic expansion in a turbine. Okay, therefore S1 is equal to S2 and S3 is equal to S4. I want you to always write this entropy for you to remember. Okay, so in 1, 2, this is occurs in pump, 2 to 3 occurs in boiler, and please write down Q in here. 3 to 4 is in a turbine, and please write down W dot out, and 4 to 1 occurs in condenser and Q out. Alright, so this is TS diagram. Please label all the axes T and S. So next is how to find thermal efficiency of a Rankine. So this is the formula W net over Q in. If you want to write the formula is in small letter, please make sure at the upper and the lower is in small letter. If you want to write it in a capital letter, please do the same way. Capital letter and capital letter. Apple to apple. So what is W net? W net is work of turbine minus work of compressor or pump divided by Q in. So WT given here as a H3 minus H4 minus H2 minus H1 divided by H3 minus H2. So it means we have to find the enthalpy for each state. Okay, since this is steam, okay, we have to know all the phase for each state.